All right, today we are diving headfirst into a wonderfully strange corner of logic and philosophy known as Ultraintuitionism. Now, this is a system that's built on questioning a rule so basic, so fundamental, you've probably never even thought to question it. Let's get into it.
So, let me just start with a question that might make you feel a little weird. What if A equals A isn't always true? I mean, the law of identity, the simple fact that a thing is always itself, what if that isn't a given? What if A equals A is something that has to be proven? Well, that is the absolutely radical starting point for ultra-intuitionistic logic.
You see, on one hand, you've got what we all believe, right? It's the bedrock of pretty much all logical systems. A is A. Seems totally obvious. But ultra-intuitionism comes along and challenges this head-on. It says, hold on. Identity isn't just some passive property a thing has. No, it's an active process, a cognitive act that you have to explicitly perform and prove.
But why? Why on earth would anyone create a system that questions something so incredibly basic? And that brings us to the real motivation behind this whole thing, what's called the identity problem.
Here's the deal. In classical logic, a contradiction is, well, it's catastrophic. It's game over. If you can prove just one single statement that is both true and false at the same time, the entire logical system can just crumble. It's called the principle of explosion, and it means that from that one tiny contradiction, you can logically prove anything is true, which means nothing is. The stakes are just incredibly high.
And that is the exact danger that ultra-intuitionistic logic, we'll just call it UIL, was designed to handle. It gives us this really powerful and pretty unique way to manage contradictions, basically stopping them from blowing up the whole system.
So how does it do it? Well, UIL's solution revolves around this one central concept, the active identification. The big idea here is that you just can't assume two things are the same, even if they look completely identical. You have to perform a very specific, deliberate cognitive act to create and then confirm that sameness. It's a constructive process. You're building the identity. It's not a given fact.
Okay, so where does this actually matter in the real world? Well, think about a computer program where you might have two variables both named A in totally different parts of the code. They look the same, but they aren't, right? UIL basically applies that kind of rigor to, well, everything. It becomes absolutely crucial when formulas look the same on paper, but you haven't actually confirmed they represent the same idea. Or think about infinite processes where you can't possibly check every single case. And it's especially critical when an identity is just a belief, something you haven't visually or directly confirmed yet.
The process itself, when you break it down, is actually pretty straightforward. First, you run into two instances of some formula. Let's call it A. They look identical. Step 2, and this is the key, you perform the explicit act of identification. You actually check if they truly are the same thing. And finally, step 3, you get your conclusion. Either the identity is confirmed or it stays unconfirmed.
Now here's where the rubber meets the road. How does this help with contradictions? Well, take that classic contradiction, A and not A. Before UIL accepts this as a system-destroying problem, it slams on the brakes and demands proof. You have to perform that act of identification to prove that the A in the first part is the exact same concept as the A in the second part.
And this brings us to the big payoff. UIL basically creates two different kinds of contradictions. You have a real contradiction where, yep, you verify the identity of A on both sides. In that case, the theory is contradictory. But, and this is the genius of it, if that identity has not been verified, it's merely an apparent contradiction. The formulas just look like they contradict. And in that case, the theory is not considered broken. The whole system survives to logic another day.
So we've seen what it does, which is pretty cool. But what is this active identification on a deeper, more philosophical level? Let's take a closer look at that. The source material explains that this act isn't just some random rule they pulled out of a hat. It's actually a form of something called constructive abstraction. It's the fundamental mechanism that ultra-intuitionistic logic uses to build all of its abstract concepts from the ground up by deliberately grouping things together and declaring them the same.
And what's so fascinating is that even though the starting point is totally radical, the mechanism itself is surprisingly, well, logical and familiar. This act of identification still has to play by the classic rules of equality. Reflexivity means A is identical to itself, but only after you've actively identified it. Symmetry means if you identify A with B, then B is also identified with A. And transitivity still holds. If A is B and B is C, then A is C. It's this really robust, structured process, built on top of a wild idea.
Okay, let's zoom out for a moment.
It's easy to look at all this and think it's just a weird niche idea, but it's actually part of a much bigger, more important story about why we even explore new logical systems in the first place.
You see, this isn't just a one-off curiosity. UIL and its predecessor intuitionistic logic are part of this major historical movement. For centuries, basically one type of logic ruled them all. But in the modern era, mathematicians and philosophers started realizing, hey, maybe there isn't just one single way to reason. And this led to a diversification of logic, with all these new systems, each with its own unique strengths.
So what's the end goal of all this? This quote from the source material just sums it up perfectly. By studying these bizarre, seemingly contradictory systems, we actually learn more about the general properties of our standard, everyday, non-contradictory theories. By pushing the boundaries, we get a much better understanding of the center. And that kind of leaves us with one final thought to chew on. Ultra-intuitionistic logic took what is maybe the most obvious truth anyone could think of and built this fascinating, coherent system just by daring to question it. So the question I want to leave you with is this: what other obvious truths in our own thinking could be completely reimagined if we just dared to look at them a little bit differently? Thanks for joining me on this one.